Texan Global School. Pythagorean Theorem. In this class, we will analyze the Pythagorean theorem and its application. Recall from previous classes that a right triangle contains a right angle or an angle of 90 degrees. According to the notation and terminology of triangles, the uppercase letters represent the angles and the lowercase letters the lengths of the sides. The elements used for the Pythagorean theorem identify the opposite side of the right angle as the hypotenuse, and the other two sides as the legs. It is important to note that the hypotenuse is the longest side of the right triangle. The Pythagorean theorem states that the sum of the squares of the legs of a right triangle is equal to the square of its hypotenuse. Algebraically, it is represented as shown on the blackboard. Specifically, the Pythagorean theorem is a relationship between areas. Given a right triangle, we will draw squares from each of its sides, as shown on the board. Then, we calculate the area of each of those squares, side times side or side squared. Hence, it can be shown that if we add the area of the square A1 with the area of the square A2, the result is equivalent to the area of the square A3. Therefore, it follows that the square of the legs, referring to the areas A1 and A2, is equivalent to the square of the hypotenuse, referring to area A3. Let's see an example. We will find the missing side of a right triangle whose given sides are A equal to 2 and B equal to 3. We will sketch the triangle as well. We can see that they are giving us legs A and B. So we substitute in the Pythagorean theorem. We then isolate the hypotenuse C, resulting the square root of 13. This irrational root is approximately equal to 3.6. Thus being the longest side of the right triangle. With the three sides, we can sketch the right triangle, legs 2 and 3, and the hypotenuse of the square root of 13, about 3.6. Since the Pythagorean theorem is an equation, we can verify by substituting values to see if the equality is satisfied. By substituting, we can see that the result is indeed correct. Another way to verify is by drawing the squares from the sides of the right triangle and calculating the areas. Area 1 is the square of 2 or 4. Area 2 is the square of 3, which is 9. And area 3 is the square of the square root of 13, which is 13. We can verify that effectively, the sum of areas 1 and 2 is equivalent to area 3. In this following example, we will find the missing side of a right triangle. One of the legs is given as B equal to 1, and the hypotenuse C equals 3. Substituting in the Pythagorean theorem, we must isolate the other leg A, which results in the square root of 8, whose standard form is 2 times the square root of 2. This irrational number is approximately 2.8, which is less than the hypotenuse. Let us sketch the right triangle with the lengths of each of its legs and the hypotenuse. We will now analyze the following application problem. Two little brothers were playing with a kite in the park, which got stuck in the highest point of a tree. To bring down the kite, they must place a ladder from the ground to the top of the tree. This ladder is 12 feet. The distance between the ladder and the base of the tree is 8 feet. What is the height of the tree? As we can see, the first thing we must do is sketch the problem. In this way, we can visualize what we should do. So, we have the hypotenuse of 12 feet and the distance of 8 feet as one of the legs. Substituting in the Pythagorean theorem results in the other leg of 4 times the square root of 5, indicating that the tree is about 8.9 feet tall. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com